Physics Guy. Bill the Physics Guy. Bill the Physics Guy.
Science rules.
Bill the Physics Guy.
Inertia is a property of matter.
Bill the Physics Guy.
T minus 7 seconds.
Bill the Physics Guy.
Oh, hello there, and welcome to Bill the Physics Guy. I'm Bill the Physics Guy, and today I will be telling you about the many applications physics has on your life. Yes, your life. Now, if you'll just follow me, we can come see some of those physics in action. As you can see, the ball was in horizontal motion before it fell off the table and became a horizontal projectile. It also moved a little bit when it fell off the table, creating a small range. In this clip, we're going to see the ball be pulled down by its own mass and acceleration of gravity. This is called the force of gravity. Roll the clip! As you can see, the ball was dropped from quite a high height, which means that it was a vertical projectile as well as moving in vertical motion. It also had the force of gravity acting upon it, and it moved for a significant distance, which means that its GPE at the top of its fall was converted all the way to kinetic energy at the very bottom of its fall, converted some to EPE, came back up, it changed more, and then eventually was all transferred to the ground. This is what we call the conservation of energy.
Bill the Physics Guy. With
Yes?
all this stuff about conservation of energy, where does work come in?
Well, roll the clip. The box you just saw had force exerted on it over a displacement, which means that it had work done on it. Even more interesting, it had worked on it over a period of time, which means that its power was consistent. The car you saw was being pushed on by a person and he was exerting a force. But as the car did not move, there was no displacement and therefore no work, and therefore no power.
But wait! What about projectiles that move at an angle?
That's a great question, and the video has the answer. As you can see, the projectile was launched at an angle, which means it had both x and y components to its velocity, acceleration, and distance. It also moved at a range, which means it covered a strip of horizontal ground. Gravity! You may not be able to see it, but the two pop cans had a gravitational pull towards each other. Anything that has mass has a pull towards anything else that has mass. This is called universal gravitation. That was a very interesting clip, wasn't it, boys and girls? It demonstrates several very important topics in physics. Number one, tension. Tension is demonstrated by the pulleys in this, and it lets both objects affect each other. Unfortunately, the tension in the ropes is canceled out because one tension is negative and the other tension is positive, and both tensions are the same. So we can't really see much of a result from this, but it does exist. Number two is the incline. The incline is a tilted plane with a certain angle measure on it. It allows for the force of gravity to have two separate components: force of gravity perpendicular and force of gravity parallel. The car had a mass and it had an acceleration, even though that acceleration was kind of small. It was moving down the ramp, which means that it had a force acting on it. So, Force times mass equals acceleration. Newton's second law.
So tell me if I'm right here. Because an acceleration is a change in velocity, and because velocity has a direction to it, by turning the car around the corner, it's accelerating in a circular path, or centripetal acceleration. This had to be created by a force, which was the force of friction between the tires and the street the car was driving on.
So, Hooke's law, which is the negative spring constant, times the stress of the spring, can be substituted into the elastic potential energy equation by substituting negative kx for force, right, Bill the Physics Guy?
That is absolutely right. Remember, EPE can be applied to anything that uses elasticity, which could be a spring, or in this case, a rubber band. The action of letting go of the spring allows the earth to pull on the toy with the force of gravity, but after that is done, it also allows the spring to pull on the toy with the force of tension. This is called Newton's third law, and it is every action has an equal and opposite reaction. It might have been hard to see, but there were two frictions involved here. One of them was static friction, the friction that only happens when something is standing still. The other was kinetic friction, which only happens when an object is in motion. It demonstrates Newton's first law, as an object in motion is likely to remain in motion, and it would have remained in motion if kinetic friction had not been acting on it. And it also would have remained at rest if Kyle hadn't acted on the books.
Thanks, Bill the Physics Guy! Now we know physics!